Ian, and I would like to welcome you to space. So, we can see many things in the universe. We can see galaxies, stars, moons, planets, comets, asteroids, meteors. We can see things on a planet, like our planet Earth. We can see houses, gorillas, birds, poison ivy, ants, and much, much more. Well, all the things you can list off as stuff you can see, touch, smell, taste. All of that only accounts for 5% of everything in the universe. What makes up the other 95% we can't see? Those things we can't see are known as dark matter and dark energy. Dark energy makes up the majority of our universe at around 70%, and dark matter is around 25%. Dark matter and dark energy are totally invisible. This is a crazy thing to think about. So really, all the things we can see, taste, touch, smell, and experience are only a very, very small percentage of everything in our universe. Now, what is dark matter and dark energy, and how do they work? To be honest, we have no idea, but what we do know is that they do exist. Let's discuss the small percentage of what we know about dark matter. So, we know it exists because if it didn't exist, galaxies couldn't form. Long ago, scientists were calculating why the universe is how it is, and they realized that there just wasn't enough ordinary matter, which is everything we can see, touch, taste, smell, and experience. So, just how did they discover this? They discovered this because scientists realized that the gravity of ordinary matter just wasn't enough to form galaxies and star clusters. The scientists just weren't sure how this could be, since from what they knew, the stars should not be able to be in galaxies, but rather scattered throughout space with the amount of gravity we know of. They were wondering, how can it be that it happened this way? Scientists Jan Oort and Fritz Zwicky in the early 1930s were some of the first to propose the idea of dark matter. They knew that there had to be something else out there, something that is invisible. Fritz Zwicky proposed this when he was studying the Coma cluster. The galaxies move around each other, and he discovered that the galaxies were moving faster than the gravity that was holding them together. This was a proposal that dark matter existed, except then they called it missing mass. This also brings us to why it's called dark matter. It is called dark matter because it does not emit or reflect light. It is dark. But the cool thing is we can actually see dark matter even though it is invisible. In places that there is a high concentration of dark matter, light bends. That shows us that there is something else out there interacting with gravity. So, let's review dark matter. So 1, there is a lot of dark matter in our universe. 2, it interacts with gravity. 3, it bends light. 4, it does not emit or reflect light. But 5, we do know it exists. So that is dark matter. Now let's move on to dark energy. So, the universe is expanding and has been since the Big Bang. From our knowledge on gravity, it is thought that the speed of the universe is expanding should be slowing down, because if you were to throw a ball up into the air, it will fall back down due to gravity. Gravity is something known as an attractive force. They studied the expansion of the universe using supernovas, which are dying stars. Due to the Doppler effect, as a race car passes, the pitch will drop. The same principle applies to the light waves from distant stars. If stars are moving towards you, they will look bluish. However, all stars are shifted to red because they are all moving away. This is evidence that the universe is expanding. If a star appears more red, it means that it is moving away from you faster. Through this, you can find out the velocity based on the brightness and find out the distance the star is away from you. So let's get back to the supernova. Scientists studied the most distant supernova and found that it was dimmer, which means further away than they expected. That gave way to a shocking discovery. The universe was not slowing down. Instead, the expansion was speeding up. The theory that the universe will begin slowing down then shrinking was well known, and that was what was believed before this discovery. That means that there must be some other form of gravity. This is known as dark energy. Yet another theory about why this is happening is known as quintessence. In quintessence, the expansion of the universe varies depending on the time. So if this is true, then maybe there is no dark energy at all. So to review dark energy, we know that 1. The universe is expanding more quickly than expected, which, 2. means that there is another gravitational force, or 3. that quintessence, a form of timed expansion, occurs. Now to sum up what we've learned today about dark matter and dark energy, let's start with that dark matter is invisible and interacts with gravity, and dark energy is what may be the reason of the universe expanding more quickly than expected. Thank you for watching.